Respected ma'am, we are Group 13 and today we are representing our DAA project and graph traversal technique specific both versus DFS and BFS. In this project, we implementing both algorithm, compare their behavior on different graphs and study their real-time applications. Let's go to the next slide. And this is our team. These members of our team, each of us contribute to understanding the algorithms and writing the code, preparing test cases, and making this presentation. Let's go to the next slide. In this slide, we are explaining about graph and traversal. A graph is a structure that contains nodes also called vertices and edges that connected them. Graphs are used in the networks and maps and social media, so on, etc. And connection and many other fields. Traversal means nothing but an visiting all nodes in a particular order. The two main techniques because on BFS and DFS. In this graph, V is nothing but an vertices and E is nothing but an edges. Let's go to the next slide. And main introduction of our project is in real-time data is often interconnected. Graph helps represent their connectivity and to explore these graphs efficiently. We use DFS and BFS. The aim of our project to implement both performance and understand where each algorithm is more suitable. And this helps us choose the right algorithm in real world and scenarios like short paths, cycle detection, network expansion, so on.
My name is Gopi Krishna. My roll number AP241100111253. BFS stands for Breadth First Search. It is a graph traversal method used to explore nodes or vertices in a graph. Key idea: BFS visit all nodes that are one edge away before moving to nodes further away. Uses a queue as its primary data structure. Ensure each node is visited only once. How BFS works: select a starting vertex, mark it as visited and enqueue it. Dequeue a vertex from the queue, visit all unvisited neighbors of that vertex, mark them visited and enqueue them. Repeat until the queue becomes empty. BFS example: starting from a node A, visited 0 to A, visit level 1, B to C. Applications of BFS: Sh- shortest shortest path is an unweighted graph, network broadcasting, spreading messages, social networking, web, AI and robotics, detecting by participate graphs, time and space complexity, time complexity, order of vertices plus edges, where V equal to number of vertices, E equal to number of edges, space complexity, order of V, due to due to the queue and visitor list. Advantages: to find the shortest path in the unweighted graphs, easy to implement using a queue, good for discovering nodes in layers. Limitations: requires more memory, no efficient for weighted graphs. Conclusion: BFS is a powerful and commonly used algorithm. It explores graphs systematically and level wise, very useful in real world network problems.
Respected ma'am, myself Ashish and my roll number is AP2411101196. Let's see about DFS or depth first search. It is a graph traversal technique where we go as deep as possible into a graph before backtracking. In this method, we start from a chosen node, mark it as visited, then move to one of its unvisited neighbors. From there, we continue exploring deeper into the graph by visiting new unvisited neighbors. If we reach a point where no unvisited nodes are left, we backtrack to the previous node and continue the process from there. DFS typically uses a stack to remember the path. This can be either an actual stack structure or recursion, which behaves like stack internally. As we traverse, every node is marked as visited to avoid the repeating same node again. This algorithm is especially helpful in tasks like detecting cycles, solving mazes, finding connected components, and topological sorting. One important point is that DFS does not guarantee the shortest path because it focuses on depth rather than distance.
I'm Rupak with roll number AP2411001118. Today I'm going to explain pseudocode for BFS. Let us start with the function wait first seeds. We begin by taking the adjacency matrix, the visitor array, and the starting node as inputs. Inside the function, we declare an integer array called q of max, which will act as our q for BFS. We also initialize array equal to -1 and friend equal to -1, which means the queue is empty because Both pointers are at -1. Next, we write q of plus plus rare equals start. This increments the rare value from -1 to 0 and stores starting node at position 0 in the queue. After inserting the starting node, we write visited of start equals -1, which marks the starting node as visited, so we do not process it again. Then we enter a while loop, while of where not equals front loop, which means the loop will run as long as there are elements inside the queue. Inside the loop, the line start equals q of plus plus front increments the front value and removes the next available element from the queue, storing it in the variable start. After removing the node, the next line printf %c/t start plus 65 prints the node by converting its numeric index into characters like a, b, c, etc. Next, the line for I equals 0, I is less than max, I plus plus. Start a loop to check all possible nodes. Inside this loop, we use the condition if adjacency of start I equals -1 and visited of I equals 0, which checks two things: whether the node is connected adjacency equals 1 and whether the node has not been visited yet. If both conditions are true, then the line q of plus plus where equals I increments the where value and adds the newly found node into the queue. Immediately after that, the visitor of I equals 1 marks these nodes as visited. This process continues until the queue becomes empty, meaning every reachable node has been visited. Next, we will have the main function. In the BFS main function, the line int visitor of max equals 0 creates a visitor array and initializes all values to 0. The line adjacency of max, I, z declares the adjacency matrix and loop variables. Then we print enter adjacency matrix and use nested loops for int I equal to 0, I less than max, I plus plus, and for z equals 0, z less than max, z plus plus to take each value of the matrix. After filling the matrix, the line function breadth first search adjacency, visited, 0 calls the BFS function and starts traversal's program from node 0. Finally returns 0 and stop program. Next we have pseudocode for BFS. In the depth first search function, we start taking by the adjacency matrix, visited array, and the starting node. Inside the function, we create an integer array stack of max and set top at -1, meaning the stack is empty. The line printf %c start plus 65 prints the starting node in alphabetical form. Then visitor of start equals 1 marks the starting node as visited. Next, stack of plus plus top equals start increments the top value and pushes the starting node onto the stack. Then we enter the loop while top is not equals -1, which means continue until the stack becomes empty. Inside the loop, we write start equals stack of which reads the top element of the stack without removing it. Then for I equals 0, I is less than max, I plus plus checks all possible nodes. If the condition adjacency of start I equals -1 and visited of I equals 0 is true, that means we found an unvisited connector node. Then the line stack of plus plus top equals I increments the top pointer and pushes the new node onto the stack. The next line printf %c I plus 65 prints the newly visited node. After printing visited of I equals 1 marks the statement as visited and the break. Statement forces DFS to immediately go deeper instead of checking other nodes. In the for loop, completely without finding any new unvisited node, the condition if I equals max, top minus minus is triggered, which decreases the top value and removes the top element from the stack. This represents backtracking. The loop continues until the stack becomes empty. completing the DFS traversal. In the DFS main function, the line int adjacency of max declares the adjacency matrix and int visited max equals 0 initializes all visitor flags to 0. Then we take matrix input as using nested. The line printf DFS traversal displays a heading for output. Next, depth first sets adjacent comma visitor comma 0 calls DFS starting from node 0. Finally, the program ends with return 0.
Hello, my name is V. Yashwantoddan. My roll number is AP241100111201. Today I am going to tell about the real world examples of BFS and DFS. BFS, breadth first search, finding the shortest path in maps or GPS, broadcasting messages in a network. When a WhatsApp server sends a broadcast message, it reaches all immediate connected users first, then the connections. This follows BFS. And the customer support ticket system, level order traversal in organizational hierarchy, and the real world examples of DFS, depth first search, are solving mazes or escape rooms, puzzle solvings like Sudoku and N-Queens, website crawlers. Search engine scrolls a web page, then goes deeper into every link inside it, and it explores depth first. And file explorer searching through folders. In BFS works like checking things level by level, such as finding the shortest route on Google Maps or processing tickets in order, whereas DFS first goes as deep as possible first, like exploring directories in a computer or solving a maze by following one path all the way before backtracking. Thank you.
Hello everyone, myself Sai Prakash and my roll number is 249. In this project helped us understand the working of two important graph transversal algorithms, BFS and DFS. BFS or breadth first search explores a graph level by level. It is especially useful for finding the shortest path in unweighted graphs. DFS or depth first search goes deep into one path before backtracking. It helps in tasks like cycle detection, backtracking, and topological sorting. Both algorithms work differently and are suited for different types of problems. That's why comparing them on various graph types shows that they shows that each has its own strengths and use cases. In real life, these algorithms are used in many fields like networking, social media, game development, and search engines. Overall, BFS and DFS are fundamental tools in computer science and are essential for solving real-world problems efficiently.